Syncing is used to automatically synchronize separate animations during blends. It operates on a system comprised of two major components, sync markers and sync groups. Here, inside of this animation graph, I have two animations, a walk loop animation and a jog loop animation. I'm currently blending them together with an alpha of 0.5, so I'm taking half of each animation, and as we can see, the animations themselves are not synced up, footsteps are in different places, and that leads to some issues when we blend, and we do not have a good-looking blend between jogging and walking. The first step we need to take to allow the engine to sync these animations is to use one of the two components that I've mentioned, sync markers. We can set them up for each of the animations that we will be syncing using a built-in animation modifier. Here we have a walk animation sequence. If I go to Edit, Plugins, and search Animation Modifier Library, here there is an animation modifier library plugin that should be enabled by default. You will want to make sure it's enabled for your project, as when it is, if we go to Window, Animation Data Modifiers, we can choose the Sync Marker Anim modifier that's part of that built-in engine plugin. I'll go ahead and right-click and tell the engine to apply the modifier. And it is going to create foot sync markers, or at least that is what it should do. However, you'll see that it created a track, but it did not place any markers on the track. And that is because force root lock is enabled, and this sync marker anim modifier uses root motion to determine when to place sync markers. So if we disable force root lock, the character is still in place, but the engine is processing the root motion of the animation that we can't observe if we disable root motion. I'll go ahead and re-enable that. And with force root to lock turned off, we can try to apply the modifier again with its default settings. And now it has given us some sync markers. I'll go ahead and re-enable force root lock. And if we look at the placement of these sync markers, we can see a pattern. A marker is placed when the bone selected as the foot bone, in this case the ball left and ball right bones of the skeleton, which exist at the joint between the foot and the toes for each foot, pass the threshold where they're perpendicular to the character's root bone, which we can see here. So when the ball right bone passes along that line drawn perpendicular to its movement, aligning with the root bone, a sync marker is placed. The same occurs with the left foot, again with the right, and then again with the left. And that is the result of applying the built-in sync marker animation modifier. I'll go ahead and save this animation and move over into our jog loop animation, and we will repeat the process. First, disabling force root lock, going to Window, and opening up the anim data modifiers window, adding a sync marker anim modifier, and applying it. Now that it's been applied, we can verify that it has placed all of the markers properly. And it looks like it has. So I'll go ahead and re-enable force root lock. And that is going to be it for the first major component, the sync markers. Now that we've set up sync markers for both of these animations, we need to set things up in our animation graph so that they are synced up, as they're not yet being synced even though we have sync markers. To sync these properly, we need to understand how the sync group system works. Animations that are being synced together are considered to be part of a group. We can define a group by providing a group name to both of these nodes, which I will name Locomotion. The engine now knows to sync these animations together. It will not, however, because we've set a method to do not sync. I'll go ahead and set this to sync group for both of these nodes. We'll be covering that third option titled graph soon in this video. With that complete, if I compile, we'll see that things are starting to sync up properly. We'll also notice that if I set the alpha to, let's say, 0.8, it is also true with its current value of 0.5, the pace matches the jogging animation, but if I set it to something lower than 0.5, like 0.3, and recompile, the speed matches the walking animation, though both animations are still being blended. This is very important to understand, as it has to do with the group role setting, which is set to can be leader for each of these nodes, which means that the pacing of the sync will be led by the node with the highest weight, as that is how the can be leader option functions and chooses a leader for the sync group. But we're getting ahead of ourselves. What is a leader and what is a follower in a sync group? Why is there a leader, and how does this all play into how things work? So a sync group can have any number of animations, but will always only have a single leader. All other animations will be considered to be followers. The playback rate of the leader will always be what it is set to in the node, or in the animation sequence asset itself, while the follower animation playback rates will all be scaled so that their sync markers align with the leading animation sync markers. As the animations can have different lengths, this needs to be done to align sync markers and make sure things are synced up properly. So this group role option determines the conditions under which a node can become a leader or a follower within a sync group. I'll go ahead and read from the documentation the descriptions for each of these options. We have can be leader, which I've already mentioned as the default behavior, and when it is selected, it causes an animation to be the leader as long as it has the highest blend weight. The next option, always follower, causes an animation to always follow the sync group leader, and if all animations in a group are set to always follower, then the first animation evaluated will be set to be the leader. Next, we have always leader, which causes the animation to always be the leader. If more than one animation in a group is set to this option, then the last one evaluated will be set to the leader. Next, we have transition leader, which causes this animation to be excluded from syncing data while blending in. Once blended in, it will become the sync group leader until blended out. Finally, we have transition follower, which causes the animation to be excluded from syncing while blending in, and once blended in, it will become a follower until blended out. These last two, transition leader and follower, are more important when thinking of things in terms of a larger state machine, where we have transitions between states, where in each state we could have different animation sequences playing while being in the same sync group. And depending on when we're transitioning in and out of a state, we may want our behavior to change for syncing, and that is where these two modes become important, though they are used much less often in general than the previous three: can be leader, always follower, and always leader. The final thing we have to cover here is the sync method option that we have not yet covered, the graph method, which clears out our group name and sets it to none automatically. And that's because if we place a sync node and provide a new group name, I'll just choose Locomotion, it will sync all previous nodes in the graph, and other nodes in the graph will view our sync node as it would view one of these sequence player nodes with its group syncing settings set up a certain way. So the sync node automatically handles grouping nodes lower down in the hierarchy together if they are set to the graph method as opposed to the sync group method. It's a newer method of syncing in the engine introduced in a more recent update. So in this video moving forward, as we set up syncing for our Locomotion system, I'll be sticking to the sync group method as opposed to the graph method, as I do not have a lot of experience using it yet. Though I did want to mention it briefly in this video, as it does deserve to have some coverage. Now that we understand how sync markers work and how the syncing system works in the engine, we can set up our syncing systems for our Locomotion system that we have been building in this series. To begin, we'll want to make sure that all of our animations that need sync markers have sync markers. And rather than applying that sync marker animation modifier one by one for each animation, we can apply it in bulk. I'll go ahead and navigate to where we're storing our animations. And because of the file structure, I'll need to go through these one by one. I'll start with the loop folder, and I will go ahead and apply an animation sequence filter. If you do not have this filters menu over here, or the animation sequence filter isn't an option, you can access it through this filters drop down. Under the animation setting, you can choose animation sequence. This will show all animation sequences, in my case, in the loop folder and any subfolder of it. And I'm going through it here at this level because if I were to just go into here, I would have to be careful not to select the idle animations or any sort of lean additives where we don't know how it would or wouldn't apply sync markers, and thus might cause some syncing issues or require us to go back and clear markers out of animations that aren't meant to have them. So I'll go ahead and go back into the highest hierarchical folder I can, while still ensuring that all animation sequences in it are ones where I will need to add sync markers into. With all these selected, I'm going to right click, and I'm going to Asset Actions, and I'm going to bulk edit them. And this will allow me to go into the root motion category and turn off force root lock for all of the selected animations. With that done, I can right click and I can choose to add a modifier to these animations. I will choose sync marker and a modifier and apply it. And I'll go ahead and select yes for the animations this modifier was already applied to, so that we override it. And here it is warning me that there's already an animation notified track and foot sync markers that already exist in one of these animations. They will exist in most, if not all, of these animations. As for the UUS animation set, the sync markers come with the animations by default. I'll go ahead and override all of them here to show you all the process. It will usually take a moment for it to process all of the animations and apply the sync markers, so I'll go ahead and cut the video, and we'll return once the sync markers have been added. All right, the sync markers have been added to all these animations, so I'll now right-click and once more, bulk edit these animations. I'll go to the root motion settings and re-enable force root lock, and then save all of the animations we've edited. I will now repeat this process for the other animation folders, though I will not show that here in this video, as that would take far too long. I'll just be repeating the process for the pivot, spin, start, and stop animations. Now that we have applied all of our sync markers, I'm going to open up the Locomotion layers animation blueprint, where we've defined the implementation for each of our Locomotion layers. I'll start with our start layer, and we have a sequence evaluator here, and I'm going to go ahead and set up its sync group settings. We're going to add it to a group named Locomotion with a capital L, as I believe the group name is case sensitive. I'll copy this here so we can paste it into the other nodes that will be synced. We'll leave it as can be leader, and we'll set it to a sync group. Next, we'll move on to our cycle layer. We'll again set the group name to Locomotion. However, the cycle sequence player will always be a follower, and it will be set to a method of sync group. Next, we have our stop layer, which will be set to can be leader with the sync group of Locomotion, and it'll be set to sync with a sync group. Next, we have our pivot layer, which contains a state machine with two states, A and B. The sequence evaluator in each of these will set to be the leader under all conditions, so always leader in the Locomotion sync group. So we will want to sync both of our pivot sequence evaluators with a method of sync group. I'll go ahead and set up the sequence evaluator in the B state the same way, a group name of Locomotion, a group role of always leader, and a method set to sync group. Finally, for the spin layer, we're going to do things a bit differently. In fact, we are not going to sync these at all. So we're going to leave these settings as their defaults. If I open up a spin animation, we don't want to sync it because there is one or more steps that takes place during the spin point, and the playback speed and positioning of this animation matters. So we don't want to scale that with the other animations. And I found that setting it to not sync and setting up our transition rule properly, we can ensure that we always enter the spin state at the start of the spin animation where it lines up with the walk or jog animation we're entering from, and exit at the end in a way where we don't get any sort of hitching issues during the transition. So we will not be syncing this state at all. With our sync methods and settings set up properly for all of our layers, we can now move back into our base animation blueprint. Over time, as we have built out the grounded Locomotion section of our Locomotion state machine, we've added states, added transitions, made adjustments, and since the previous time we've seen any of these values, I've been making adjustments in a project where I've been developing the system in full, and I've finalized the blend settings for all the transitions in this portion of the state machine, and I wanted to go over those here in this video so that I can consolidate all of that information into a single place. I'll start with the idle state. The transition from idle to start will have inertialized blend logic, the fast feet blend profile selected in a duration of 0.15 with the Hermite cubic in-out blend mode. Stop into idle will have an inertialization blend logic mode selected, a duration of 0.75 with everything else default as you see on screen here. For the start state, we have the 3 transitions to cycle, which share the same settings, a duration of 0.3, a standard blend, and, well, default blend mode and blend profile of none. For cycle to spin, we have a duration of 0.2, a standard blend, and, well, really everything here is default, and as you see it on my screen. For spin to cycle, the first one, where we have an automatic roll, we have a duration of 0.25 and everything else set to the default values. For the direction-based condition, we have full default values for the transition. For gate changed, again, we have full default values. Finally, for spin to stop, we have a duration of 0.25 and a blend profile of fast feet with everything else being set to default. Next, looking at our pivot alias transition blend settings, we're using a standard blend and default settings across the board again here. For the pivot to a cycle transition that's based on our animation notify state being active and the animation being played, we have a priority order of 2, a standard blend, and a duration of 0.5 with the other settings being default. And for a condition based on the dot product of our acceleration and velocity, we have default settings, but with a blend logic mode set to inertialization. For pivot to stop, we have a duration of 0.25 and a blend profile of fast feet, with the blend logic set to be a standard blend. For cycle to stop, we have inertialization selected with a fast feet blend profile and a duration of 0.25, with the mode being the default. Finally, We have start to stop, which is the duration of 0.15 and a standard blend with all settings other than the duration being set to default. And for stop to start, it's set up the exact same way, defaults except for the duration being set to 0.15. Finally, we have stop to idle, which is set to be an inertialized blend with a duration of 0.75 and all other settings default. I went through that a bit fast, but you can pause the video on each of these transitions as I select each one and copy my settings over, and your transition blend logic will match mine. And again, this is for the UUS animations that I'm using here. These may need to be different if you're using different animations, though I've been running tests with the Lyra animations in my own version of the project, and if you're following along with those, these settings should all work properly. Additionally, for the transition from cycle to spin, if you've implemented a spin state, I'm going to make an adjustment to this section of our condition where we check the time remaining in our source cycle state. Right now, we're just checking if it's less than or equal to 0.05. I'm going to delete that, and I'm going to subtract our actual crossfade transition duration from cycle to spin. So I'll type crossfade, and I'll get the get transition crossfade duration function. And I'll check if this is less than or equal to 0. And this will make this transition timing based on the timing we set in this transition as opposed to a hard-coded value as it was set to previously. And that is the finalized adjustments to the transition rules and blending from the project that I've been developing for the full version of this system that I'm creating more slowly here for the YouTube series. Finally, we have our pivot state, or layer, where we have a state machine in two states. And we're going to adjust these transition blend settings as well. These settings are going to be the same. The duration is going to be set to 0.15 as an inertialized blend with a fast beat blend profile. And with all of that done, we can see the end result of our settings here with our transitions between all the states. Things should be syncing properly. We should be seeing no sort of footstep hitches, and these spins should look all right as well.